Dr. Wang here recording. In this video clip, I'm showing you how to do quiz number 6. So this quiz is a little bit special. As long as you follow my instruction here, then this quiz is done. And it's more like a bonus point to you guys as long as you follow. Alright, so in this quiz, we have the data for SPDR ETF. And ETF stands for Exchange Traded Fund. It is a financial product which is a portfolio of a number of securities. And this SPDR ETF is including Standard & Poor 500 stocks. So you know Standard & Poor 500 is what we used to represent the US stock market. That includes the best 500 stocks. We can say that. So those are most liquid, the largest, the most profitable, the stablest stocks in the country. All right, and in this ETF, it just mimic the Standard & Poor 500 index. Okay, you see a Standard & Poor 500 index is different from this ETF. The ETF just mimic the index with the same weights in the same stock, but at lower volume. As you can see, the assets under management is $6.7 billion, but you know the market capitalization of all the 500 stocks in this index is much larger than that. Apple by itself is $2 trillion. It's much larger than this ETF. So the ETF at the bottom line is a portfolio including the stocks that were included in Standard & Poor 500 index. Okay, so what you're going to do here is to calculate the expected return standard deviation, and then you're gonna annualize it and based on the daily data and the monthly data. So this quiz is actually very close to your class exercise number 3. And I just put it here, just give you some extra practice so you can be better prepared for your midterm exam. All right, so you can see right here, you have the daily data for SPDR ETF. Once again, SPYD is for the Standard & Poor 500 Index High Dividend Yield ETF. All right, so you have a daily data here, you have monthly data here, and they all come with the same amount. So even though you have like roughly 50 data points, 50 prices, but if you go with the daily, so that's the 50 days. If you go with the monthly, that's the 50 month. So they cover different length of time period. All right. So the first thing you can do is to get the return. You're gonna use the later return divided by the earlier return minus 1. So that's the very first thing we learn in this class. Okay. And then you go with the monthly, same old trick. Okay, and then you're gonna use a later price divided by earlier price minus 1. So right here you see the prices are sorted in ascending order. If not, let's say if they are ascending in descending order, if they are arranged in a descending order, so let me just select that. So I go with a sort, and then sort by month. I go with the newest to oldest. So you can see that if it goes this way, from October to September to August, it's just to go to the older dates, then your calculation is different. So you should use the later price, okay, divided by the earlier price. It's the same formula, but this time the earlier price is underneath. Okay, so that's how you calculate the return if it is in a descending order. So let me just recoup what the original setting. So again, you go to data, you go to sort, you see under data tab, sort, and you're gonna sort the month from oldest to the newest. Okay. And then let's just finish up this return calculation. Newer divided by earlier minus 1. Okay, so that's the periodical returns, and then you need to calculate the expected and standard deviation. So let me just go with expected and the standard deviation. You can see it's a little bit hard for me to read all of the data. Actually, I don't need to read all of the data, but if I do the calculation here, I have to scroll all the way down every time. So there is a way that I can avoid doing this. So I just select this rows in the middle, and then I go to data. Okay, I go to data, then I click on group. Okay, so after click on the group, you will see that I can just I have two buttons here. I can just click on one button. Okay, and this way the middle buttons are hidden. They are hidden, they are not deleted, so the data are still there. If I click on number 2, they're still there. If I click on number 1, then I saved a lot of room for me to perform the calculation. So to get the expected return, I just go with the average, then select all of them. Okay, from C3 to C54. All right, and I'm gonna do the same. Okay, from row 3 to row 54. For standard deviation, STDEV, nice and easy. Select the returns above. Select the returns above. Okay, so you can see that no matter I expand the view or shrink the view, the result is not affected because they have the same, because the cells they include, they used, is not changed whether I expand or not. All right, so the next thing I want to do is based on question from based on the answer from question 1, please solve for the expected return and the standard deviation at the annual level. So you are solving for the annual expected return and annual standard deviation, and what you have here is the arithmetic. Okay, arithmetic mean. So for the annual expected return, what you can do is to use the daily average times the number of days in a year. Well, you need to know that in the stock market there are 252 trading days, not 360. Well, there are 365 calendar days, but if we are talking about the stock market, only 252 days in a year are available for stock trading. And of course, the weekends, Christmas, Thanksgiving are not included in this 252 days. So you simply use the daily average multiplied by the number of days in a year, and then you can get the result. And for this one, you can use the daily, the monthly times 12, because there are 12 months in a year. And this result is showing you a large discrepancy, because if you look at the performance for these days, 50 days or so, the performance is not good. The performance is actually dropping by 0.2% times 250, so that's 52%, and that's a little bit misleading. So if you want to get the annualized return, the monthly return would be a better method. Okay, the next one. So you gotta get the annualized standard deviation. All right, and the annual standard deviation, if you use a monthly, if you use the daily, then it's a daily standard deviation times the square root of number of days, trading days in a year, 252. Okay, so that's what it gives you. All right, and then I'm going to do the same thing. I'm going to use monthly standard deviation multiplied by the square root, not 12. Okay, it's the square root of 12. Okay, so that's a 24%. And now it is getting close. So if you are measuring the risk at annual level, they are closer, whether you use a daily or monthly. Okay, let's see. My next question is please calculate the holding period return for the whole 2 columns of data. So for the holding period return, it's actually pretty easy to do. So holding period return, or HPR, equals to the latest price, not return, latest price divided by the earliest price, okay, the -1. All right, and I can just drag it all the way down and delete the middle cells. I don't need them. Okay, so what you see here is for this 50 days from February 2023 to May 2023, the stock dropped by 10% or so. But if you look at a longer time horizon from 2019 to 2023, the stock actually increased by 11.51%, okay, in a 50-month period. Okay, and then the last question here is to analyze the holding period return to obtain the annual percentage rate. Okay, so we're still getting the annual expected annual return. Okay, but this time it's based on the holding period return. So this time we are going to use the geometric method. So I'm going to use 1 plus the holding period return. Okay, that's the formula you should use. Raised to the power of 1 over n. Okay, n is a number of years in the holding period. Okay, in the holding period, but I can't just type it in because I need to figure it out myself. So how many years in this data range, or what's the fraction of the year covered by 50 days? So that's the number of years. So I'm going to use a count function. So I'm going to count how many returns are there from February the 17th to May the 3rd. Okay, and then I will use it divided by 252 trading days, and that's gonna give me roughly 20% of the year. All right, so 50 days is about 20% of the data for the year of 250. Okay, and then I'm going to close the parentheses, and after that I'm going to subtract it by 1. Okay, so this is the geometric way to get the annual return. And to get the same stuff with the monthly return, again, I'm going to use 1 plus the holding period return. But you know, the holding period return by itself is the ending price divided by the earlier price minus 1. If I add 1 here, then it's going to automatically cancel the -1 effect. So I can just simply use the ending price divided by the earlier price, okay, then raised to the power of 1 over n, and n is the number of years in this time period. So I'm going to count how many returns here. Okay. Okay, roughly that's 51 month, and then divided by 12. Okay, divided by 12, and make sure this is covered in parentheses. Okay, so this is the count. 52 months divided by 12 months, that's the number of years in this time period. And I'm using 1 divided by that. Okay, and after that, close the parentheses, -1. Hit enter. So each year, in a geometric way, the return is 2.55%. Okay.